In previous chapter, mechanical properties of solids, we discussed only the properties of solids only we discussed. Here, we are going to discuss about fluids. Any substance which can flow is called fluid. That means two things comes here, two types of matter, that is liquids and gases. Both can be called as fluids. Both can be considered here when we are studying about mechanical properties of fluids. Okay. Now, in this some basic definitions we will discuss, and we will continue further into the chapter. So fluids are what? Gases and liquids. Both can be treated as fluids. Now the basic and first definition is pressure. Pressure. So pressure is denoted by letter P. Okay, it is denoted by letter P. Now, so we know the definition. It is a basic definition only. Suppose if I have some area over here, and on this area, some surface is there. On the surface, if I apply force, on it in this particular direction. Okay, if I apply force on it in this particular direction, now uh, this particular force, if it is acting in this particular direction, now, so the force, how the force is acting? Perpendicular to the surface. If any force acts perpendicular, then that particular force we call it as a thrust. Okay, so that particular force we call it as thrust. And how much area it is acting, that we will consider. Okay, so the thrust, how much it is acting. Now, uh, thrust acting per unit area. Thrust acting per unit area, we will consider it as pressure. So pressure is taken as a thrust acting on unit area. We call it as pressure. So same thing, similar definition we got there for stress also. So that means units will be same here. So what we will have units? SI units if I write, SI unit if I write, what we will get? Thrust is nothing but pressure, force only, force per unit area. Newton per meter square, we call it as a pressure. Right? Now, so that is about the pressure part. And generally, we can use this pressure in Newton per meter square. We call it as Pascal. PA we will be representing, and common unit we will take it as ATM. That means atmospheric pressure we call. So one ATM value, if we write one ATM, we will write it as 1.013 into 1.013 into 1.013 into 10 to the power of 5 Pascal. Into the power of 5 Pascal we will write. This is one ATM value in terms of Pascals. And when we go with the dimensional formula, so Newton dimensional formula is m L square T to the power of pressure, no, m L T to the power of minus 2, and area is what? L to the power of minus 2. It is L square. When it goes up, L to the power of minus 2. So we'll write it as m L inverse T to the power of minus 2 is dimensional formula of pressure. Okay, so that is about dimensional formula of pressure. Now, so next topic is we will go with the what is mean by density, and we will continue. Just, right. So that is about pressure, and we will move with the next concept, density. So density. Density, what we define density means mass density we can call. So density is defined as what? The ratio of mass and volume. Density is denoted by rho. So we will take it as mass by volume. We will consider it as the amount of mass present in a unit volume. We consider it as density. Okay, mass by volume we will be writing. The amount of mass present in unit volume we will consider it as density. Now what about units of this? SI units only I am mentioning here. So mass unit is kg and volume unit is a meter cube. Kg per meter cube we will write, and CGS unit if we write gram per cc will write gram per centimeter cube, and it's a dimensional formula. When it comes to dimensional formula of this, what we will write? So mass dimensional formula is m, okay, and this is volume is meter cube we are writing now, so it's dimensional formula L cube we will write, and T is not there, so I'm writing T power 0. So this is dimensional formula of density. Okay, next. Here we will have one more concept called relative density. That means we will be comparing density of a substance with some other substance. The other substance usually we will consider it as water, which is lying at 4 degrees Celsius. Okay, no. So what is the next topic? Relative density. Relative density. Relative density. And the relative density we will consider it as the ratio of what we write, the ratio of the ratio of density of a substance, density of a substance, density of a substance to the density of water, to the density of water, the density of water, and the water should be at 4 degrees Celsius. So density of water and the density of a substance. So relative density, if we write, what we can write expression for relative density directly now. So what we are writing, density of substance. So we can find density of substances by using this formula. Okay, density of substance, and next one is what? Density of water. Okay, their ratio only we are calling it as a relative density. Okay, density of water. Now, and this water is at a 4 degrees Celsius, we will consider. This is what we call it as the relative density. And here it is not having any units, that we have to keep in mind, because it is a ratio of same quantities. Okay, so as it is ratio of same quantities, so it is units. If we write, when it comes to units part, it is not having any units. So we will write it as no units. It is about relative density and density concept. And some density values may be useful, that I'll give you some density values. I'll write in the next page. Densities of some substances we will write. Those we will be using in some problematic part. So we will continue with that. So if you write densities of some substances, densities of some substances, if you write densities of some substances, if you write, so usually water, this is most useful value. So water density if we write, so we'll write it as 1.00. That means one only, up to 2 digits of approximation we are writing. Significant figures, two significant figures we are writing into 10 to the power of 3 kg per meter cube. This is water density, 1 into 10 to the power of 3. That means 1000 kg per meter cube. Or if we write in CGS units, 1 gram per centimeter cube. CC will write 1 gram per CC. CC is nothing but centimeter cube. Now, so that is about water. And if we write for salt water, we write for salt water, so we will have a value of little higher than this, 1.03 into 10 to the power of 3 kg per meter cube. Almost same, little difference from here to there. Okay, so that means this is if I multiply this, so how much it is? 1.00 means 1000 it will come. And if I multiply 10 30 it will come. Okay, that is what the salt water density. And mercury, if we write mercury density is 13.6 into 10 to the power of 3 kg per meter cube. So high density material it is. Okay, it is a metal, high density metal. And this is simple one, air. So air will be having a density of 1.29 kg per meter cube. So these are the different values of densities which we will come across in general, right? So that is about the density values. Next we will go with the problem, then we will continue with the next topic. Okay, so how gravitational value changed with respect to altitude and depth. Here also we'll check how pressure changes with respect to depth. That also we'll check. That is next topic. So before that we will try to solve this problem and we'll continue with the next topic. Question is here, problem no? So the two thigh bones, this is there in the academic textbook. That's the reason I'm covering this problem. The two thigh bones, the two thigh bones, these are usually thigh bones are the strongest. Thigh bones we call it as femur in general. Femur. Okay, so two are there, so femurs. Each of cross sectional area, each of cross sectional area, each of cross sectional area, each of cross sectional area 10 centimeters square. So area is given 10 centimeters square. Support the upper part of human body. Support the upper part of human body. Support upper part of human body of mass 40 kg. Of mass 40 kg. Estimate the average pressure sustained by the femurs. Estimate the average pressure sustained by the femurs. First we'll try to write given values, then I'll continue with the diagrammatic part and how it will be done. So what is given? Mass is given, how much? 40 kg. So it is in standard units, no problem with that. Next area is given. Okay, so area is what? 10 centimeters square. Okay, and we have to add 10 centimeters square one more. I will tell you why we are adding. 20 centimeters square we will be having. 20 centimeters square is there, but here it is in kg, so we have to convert it into meters units. 20 into each centimeter is what? 10 to the power of minus 2 meters. Okay, so minus 2 whole square, this is in meter square. Now, so what we got? 10 to the 20 into 10 to the power of minus 4 meter square we will be having. Okay, so this is the area. Now why we have taken double, that I will try to explain here. Suppose there is a person over there. No. So he's just simply standing by holding his hands like this. Now, so what is happening up to this part? So which part I am speaking about? His thigh bones. These thigh bones are having cross-sectional area of 10 centimeters square. So as two thigh bones are there, so these two thigh bones are holding this total body. Okay, This total body is upper part of the body is having 40 kg. This 40 kg is holded by the two thigh bones, not single thigh bone. That is the reason area of both I have to consider. That is the reason I have considered area of the both. Okay, so that is what exactly the problem is about. Okay, the person is there, he is standing, and when he is standing, both the thigh bones are how much weight they are, how much mass they are carrying, combinedly 40 kg they are holding. Okay, so both the areas we have to consider, both areas if I consider, this much I got. Now, so I got only mass and area, but pressure formula is what? Pressure formula, force into, sorry, force by area, right? Thrust acting on unit area. So pressure is equals to thrust acting on unit area. Thrust means what? How much force is acting normal to these thigh bones. So force is acting on those thigh bones in this direction. That means in this direction, whatever force acts, that we consider it as mg. So if we can write, so F can be written as now mg, because thigh bones are in this way and the force is acting downwards. If the force acts downwards, we can consider that as the mg. So mg I am considering that if we write mg by A, we can write now if we substitute in this. So m is what? 40, that is in kg only, into 20. Okay, sorry, not into 20. It is g, no? G value I'm considering it as 10. 10 by 20 into 10 to the power of minus 4. Okay, now this 0 and this 0 cancelled, 2 2s are. Okay, 2, and 10 to the power of minus 4, here 1 is there. 10 to the power of minus 4, if it goes up, 10 to the power of plus 4 it becomes, and 10 to the power of plus 4, next 10 to the power of 1. So total it will become 10 to the power of 5. So already 2 is there, right? So 2 if it is there. So what we can get? 2 into 10 to the power of 5 we can get. Okay. This 4, when it goes up, plus 4 it becomes, and already 1 is there. 4 plus 1, 5. Only 2 is left out. Okay. So this is what the pressure value acting on the average pressure acting on the femurs. Okay. So I hope it is clear, and we will go with the next topic. Next topic is what? Pressure. What is the value of pressure? How the pressure changes with the depth. Okay, that will see. Right. So in this, we have a variation of pressure with depth. That is what I have taken some container, in that some water is or some liquid is present in it. So if I place some cylindrical arrangement into this, if I place a cylindrical arrangement into that, then what is this cylindrical body applying force in it? What is the cylindrical body force applying, that we have to consider? So mg, I am writing it as rho into v, because rho is equals to mass by volume we have. So mass is equals to volume into rho, rho into V we can write. That I have used here, because they didn't give me mass of it, only its density we know, and its area, its height we know. So volume into rho into G I am writing. So volume is not given, only area and height is given. So volume can be written as area into height into rho into G. Now, so from here, A I am sending other side, F by A it will become H rho G. So, but F by A is nothing but our pressure. So, pressure is equals to, so we got it as rho G H we got, right? H rho G or rho G H. This is pressure exerted by the liquids at depth H. And so this is what pressure exerted by the liquids at depth H. Now, if we consider atmospheric pressure also, so because here atmospheric pressure also exerts, that we consider it as P0. So this is what is the pressure exerted. Suppose if this force is acting, if this weight is acting downwards, the liquid also acts some force on it, and that means the liquid also exerting some pressure on it. So that pressure expression is rho hg, and atmospheric pressure also acts on this. Okay, so two pressures acts on that liquid. So that if we write, so what we can write, rho can be written as rho naught plus, sorry, not rho naught, we are writing pressure part, no. So atmospheric pressure is P, not. So total pressure if we write P naught plus rho g h, h rho g I am writing it as rho g h. Now so here whatever terms we have in this, the terms we have in it is P is what? Absolute pressure. P is absolute pressure. P is absolute pressure. Next, P naught is what? Already I told, atmospheric pressure will act on the surface of the liquid. So this is the atmospheric pressure. Atmospheric pressure. Atmospheric pressure. Next. Next one is what? Rho GH. Rho GH is what? Gauge pressure we call. Rho GH we call it as gauge pressure. GAUGE, gauge pressure we call. It comes in class 9 also. Now, so if I want to write an expression for gauge pressure, so gauge pressure expression we will write it as rho GH is equals to P minus P naught we will be writing. Okay, this is the expression for gauge pressure. Sometimes in the exam they will ask derive an expression for gauge pressure. That time we need to write up to here. Okay, so that is about pressure at depth. Pressure at depth is what? Rho GH. So not only at rho GH, there also one more pressure, atmospheric pressure also exerts on the liquid, that if we consider. So this is exerting pressure and atmospheric pressure also exerting. Both combinedly we can consider the pressure acting on the liquid, that is P naught plus rho GH. So if I write only, uh, just hold on, topic is completed. No?